Hello, everyone, and thank you all for joining us on this webinar today on Renew America's Schools. My name is Michael, and I'm part of the business operations team here at R0. It looks like the room is just starting to fill up, so I think we can go ahead and get started on this next page with the agenda. So we'll be spending a few minutes reviewing what the Renew America's Schools program is and the key steps in submitting a proposal. Then we'll share some information on R0 and how our solutions can help you create a healthier and more energy efficient environment for your students and staff. I'll be starting off with a grant overview, and then my colleague Uri here on the screen will walk us through the R0 platform for energy efficiency and IAQ. So if we turn to the next page.
And just before we do that, Michael, just for everybody who's joining, if you have any questions, any comments, feel free to add them into the chat or the Q&A. And we have a few other folks helping Michael and myself today, and we will be answering those questions as we get them, as well as leave plenty of time toward the end. So please don't be shy. Okay, back to you, Michael.
Thanks, Uri. So presenting today, myself on the business operations team, my colleague Uri, who is our VP of product marketing here at R0. So starting with an overview of the program, Renew America Schools is a $500 million program launched by the Department of Energy to help public schools reduce energy use and improve indoor air quality by upgrading their existing facilities. In 2023, the program announced $178 million to round one selectees, and applications for round two are currently being accepted, and there's exactly 1 month left before the June 13th deadline. Each of the selectees for this program will ultimately receive $7 to $14 million to implement energy efficiency and air quality projects. And the size of the grant will ultimately be determined by the number of schools in your application's portfolio. The next slide summarizes the 3 phases of the program. From the applicant pool, the DOE will select up to 23 winners. Each of the selectees must have at least 10 schools in their application portfolio. And if your district does not have 10 schools, the DOE recommends partnering with another district as well. In phase 1, applicants will assemble their project teams, the portfolio of school facilities, demonstrate the need for energy improvements, and outline their plans for energy and air quality improvements. The selectees in this round will receive a $300,000 cash prize and move on to phase 2, where they will begin negotiations with the Department of Energy on a cooperative agreement. In phase 2, the selectees will conduct ASHRAE Level 2 energy audits and develop comprehensive plans for implementing energy and air quality improvements. The $500,000 to $1 million in funding granted to each selectee in this phase will be used to reimburse costs related to energy audits as well as strategic planning. So phase 3 is where the project implementation actually occurs. So in this phase, you'll oversee the deployment of projects developed in phase 2. Here, the DOE will allocate the bulk of the funds for the projects, and as a reminder, there's also a 25% cost share for this phase of the project. Now turning to the application process and timeline on the next page. Most importantly, all the relevant information and application submission will happen on the HeroX platform at herox.com/renewschoolsprize, including links to past webinars and FAQs. You can also find this link on the Renew America Schools homepage. Many of you have already registered and have begun working through the submission materials, but if you haven't had a chance yet, we highly encourage you to register on the platform as soon as possible to ensure that you have sufficient time to get all the information together. In the next section of this presentation, we'll be going over R0 solutions for energy efficiency and IAQ. If you're interested in partnering with us for this program, please reach out after the webinar and we can provide you with information for the application and help you on any of the relevant parts. One important thing to note is that the DOE encourages proposals with multiple projects. So if you're already planning to include upgrades to your HVAC or lighting systems in your application, you can also incorporate solutions from R0 to drive further efficiencies and air quality improvements. And with that, I'll turn it over to my colleague Uri, who will provide an overview of our solutions.
Thank you very much. So let's first start by why this is so important now. What's driving the emphasis here? First of all, we all know that there's a huge emphasis that is relatively new in the last few years on indoor air quality. We see that from ASHRAE. Michael just mentioned ASHRAE audits as part of the grant process. So ASHRAE put out a new standard 241 about a year ago on how to manage indoor air quality in periods of increased infection risk. And that standard really has pushed the kind of state of the art in terms of the amount of fresh air that's needed, the amount of clean air that's needed, about 3x or more, as we'll see shortly. The CDC similarly put out guidance recommending at least 5 equivalent air changes per hour in occupied space. And the Lancet, which is a very well regarded medical journal, published research that suggested 6 or greater equivalent air changes per hour is best. At the same time as there's all of this push for greater indoor air quality and more air changes per hour, there's also, of course, a push toward reducing energy. And this grant really encapsulates both of those two efforts in our broader society at the same time. On the energy side, of course, Local Law 97 in New York City is a good example of some of the changes that are happening around the country to drive down energy and emissions. So if we look at what that guidance is that I just mentioned from ASHRAE and the CDC, for example, you can see the difference between ASHRAE's prior guidance in blue and their current guidance in ASHRAE 241 in green. So you can see that, especially in gyms and cafeterias, they have recommended increasing by 3 or more times the amount of equivalent air changes every single hour. And the reality is that to deliver 14 air changes per hour in a cafeteria, or even 6 in a lecture hall, it's very difficult to do that with existing HVAC, because existing HVAC was not built for that. And it is frankly very, very expensive to run it that hard, as we'll see in a moment. And just for comparison here, the CDC guidance of 5 is in red across the board as well. So you can see that in ASHRAE's guidance, certain spaces that are either densely occupied or that are very boisterous or where people are very physically active tend to have higher infection risk. And that's why those green bars, are the highest. And this chart, by the way, is from the Center of Green Schools, which has been doing work on this topic. They also published this really helpful graphic that shows you the different options for trying to improve the number of air changes per hour and increase the amount of clean air that's available to people inside your buildings. So, of course, you can increase the amount of outside air that you bring in, if possible. You can also clean the air that you have through higher level filtration. That's what that MERV 11 or greater example is at the top right. You can reduce the number of people in your space, not so easy. That, of course, increases the amount of air available to each person. You can clean the air in the space with an in-room air cleaning system, or you can clean the air with ultraviolet light shining across the top of the room, which we'll talk a little bit more about later. And all of those options, or a combination of those options, are all available to you to try to increase the clean air exchange in your space. Now, the Department of Energy's Pacific Northwest National Lab just put out a piece of research a couple of weeks ago showing comparing some of these different options and how expensive they are in terms of energy use. So this chart shows you the kilowatt hours required to increase air changes just by 1. And remember, if we go back a couple of slides, the recommendation here from ASHRAE in a lecture hall is to go from just over 3 to just over 6. In a gym, it's to go from 4 to 13. So this is not a 1 air change per hour increase. These are many air changes per hour. Just keep that in mind. But if you just look at it per 1 air change per hour, how much energy is needed, that's what this chart is all about. And what it shows you is that either cleaning the air in the duct with UV, or bringing in more outside air, or increasing filtration from MERV 8 to MERV 13 filters, all of those options are very energy intensive. They use more than 2.5 kilowatt hours for every air change. So if you think that you're going to increase air changes by 3 or 6 or 10, you need to multiply this number by the number of air changes per hour. And that, of course, is going to add up very, very quickly. On the lower end of energy use, you have portable air cleaners and in-room UV, either upper room UV or far UV. The trouble with portable air cleaners is that they're noisy, which means people often turn them off. They're drafty. They create, a feeling of air moving in the room, which is uncomfortable. Another reason people often turn them off. They're hard to maintain. You have to replace their filters. So happens my wife is a teacher and had one of these in her room, and discovered a year after it was installed, when they came in to change the filters, that the original filters had never actually had the plastic wrap taken off of them. So it was not effective at all. So there are a lot of challenges with making these actually work in physical space, especially across a wide range of spaces like you have in a school district. In addition to that, upper room UV or in-room UV in general turns off, or can turn off, when rooms are empty. If it's able to detect presence, it can turn off when rooms are empty. So the amount of energy use that it requires is actually even lower than what's represented here, because this paper did not take into account the fact that UV can be turned off when no one is in the space. And of course, in a typical school building, people are only in the space a part of the time, not 24/7. And so UV actually comes out even better once you take that into account. So let's talk a little bit about how R0 can help you in your submission package in greater detail. First of all, what is R0? R0 is a building intelligence company, and we make a platform that delivers insights based on real-time occupancy and air quality data, uses that to give you recommendations and to directly control how you use your building. A few examples of that are smart cleaning, which helps your janitorial team prioritize the spaces that got the most use that day. Energy savings and greater comfort by matching the ventilation that you provide to the actual occupancy in that space in real time, and measuring air quality in your spaces at the same time, and also improving HVAC filter efficiency. And air and surface disinfection with in-room and mobile UVC that helps to automatically and continuously kill pathogens and odor-causing bacteria while reducing the use of harmful chemicals. So this platform sits on top of some pretty sophisticated hardware. So our monitoring and disinfection ecosystem includes everything from UV disinfection to occupancy counting and air and environmental sensors. So from the left here, you have ARC, which is our mobile UVC tower that you wheel around. We'll talk a bit more about that a little later. That disinfects unoccupied spaces, typically at the end of the day. We have a number of far UV products that are used in spaces where people are occupying them and you want to provide continuous disinfection. Far UV is completely safe for a human presence. We have Beam, which is our upper room UVC product, which provides 12 or greater equivalent air changes every hour. And then we have sensors that measure occupancy, that measure presence, and that measure air quality. So using these sensors and UVC products, we're able to both deliver the insights, the recommendations, and the direct changes to your HVAC system that I described on the previous slide. So let's talk about air quality first. Why is air quality so important? Well, first of all, we just talked about what we've learned from the CDC and ASHRAE, and of course, what we all experienced over the last few years. But we all know, of course, that indoor air quality is also really important for our comfort, for our productivity, and for learning. But it's not really just the air quality that matters. It's also light, it's noise that can also affect how effective people are at operating in a space. And that's why we also measure those in our sensor. So our indoor air quality offering rests on the foundation of the hardware that I shared with you, and builds on top of that sophisticated analysis that supports easy to use monitoring tools. So, and of course, on top of that, we also have the ability to control HVAC to ensure that you're able to moderate your HVAC use when possible, but also prevent any downsides that might happen to indoor air quality. We're always monitoring that indoor air quality. So if for whatever reason you have low occupancy, but an indoor air quality problem, maybe somebody burned popcorn in the microwave, for example, we will recognize that and be able to ensure that the HVAC is working and keeping everybody healthy and productive. So here are just a few examples of kind of what the indoor air quality offering allows. And that's built, as I said, on our leading sensor. And this sensor is able to measure a wide range of parameters. I won't go into all the detail on this, but suffice it to say that there's a set of parameters that are typically considered sort of standard indoor air quality measures. Those also are important for getting RESET accreditation. And RESET is a standard for accrediting air quality monitors that is often also used and referred to in other standards for healthy and clean and green buildings like LEED and WELL and Fitwel. We also measure some more advanced indoor air quality measures. I'll call out formaldehyde here. Formaldehyde is an interesting one, especially if you are retrofitting a school or building a new school or bringing in new furnishings, oftentimes there's off-gassing from that material, and it's very often formaldehyde. And by measuring formaldehyde, especially when there's a new build or new material in the building, we can tell you, hey, this is fully vented and it's now safe for occupancy. And I already mentioned before the importance of also measuring noise and light, because those really help to ensure that a space is comfortable for its occupants. On the energy efficiency side, I want to talk a little bit about what we're doing to really take demand control ventilation to the next level. So demand control ventilation is basically the idea that you want to have as much ventilation as you need based on the number of people that are in a space. And conventionally, this has been done by using CO2 sensors that are either mounted inside the HVAC return duct or sometimes on the wall. The problem with that method, which has been in use for about 40 years now, is that sensors are not very accurate. Depending on where they are in the room, the readings can vary pretty dramatically. They're also pretty expensive to maintain. They tend to need to be calibrated or replaced every 3, 4, or 5 years. And they're slow to respond. So CO2, measuring CO2 is a proxy of how many people you have in your space. It's not actually how many people you have in your space. And of course, it doesn't respond immediately. So if 30 people walk into an empty classroom, that CO2 level is going to build up slowly. Eventually, it's going to trip the CO2 sensor to tell the HVAC system to turn on, but that might take 30 or 40 minutes, during which time people start to feel drowsy, start to feel stuffy. The room starts to feel stuffy and generally not a pleasant experience. If those 30 people then walk out of that room, the CO2 level is going to take some time to decrease. So meanwhile, the HVAC system still thinks it needs to be running to clean out that air, even though no one's in the space anymore. So that slow response time is pretty costly from an HVAC efficiency and energy perspective. On the other hand, what we do is we use our sensors to actually count the number of people walking into every door in real time. And so we always know there's 30 people in here, there's 10 people in here, one person walked in, one person walked out. And that enables us to tell the HVAC system very directly and immediately what it needs to do from a ventilation perspective. So that increases the energy savings that are possible. And these sensors are less expensive to both install from a hardware perspective, and they never need to be replaced. So the total cost of sensor hardware and maintenance is also lower. And because they're responding immediately, it's keeping people more comfortable as they go. So how does this actually work? So as I said, when people come in or out of a space, we can detect that and basically keep track of how many people are in that room or passing through a particular HVAC zone. Our software then calculates how much ventilation is required in each zone and tells the HVAC to respond accordingly. And so here's an example of the impact that that can have. So the baseline here is continuous ventilation. Basically, it's running the same rate all the time, similar to the system you might have in your home. It's either on or off. The next kind of innovation on top of that is temperature-based controls. So this is where if the temperature is off by more from your set point, it increases the ventilation power to try to catch up. That saves about 9% on average across the US over just a flat on or off. Conventional demand control ventilation using CO2 will save an additional 6% or about 15%. And what we've now innovated with much higher accuracy based occupant based controls is another almost 15%. So it's almost double the amount of savings that you can get from conventional demand control ventilation. So it's a pretty dramatic increase over what's been possible in the past. And it really just boils down to really making sure that the HVAC is aligned to how many people you have in your space in real time. And as I said, that increased performance not only has an energy savings benefit, it also means that people are going to feel more comfortable in that space. You don't have the lag. And as a consequence, you don't have the effects of that lag, like kids getting tired and being less productive in their learning environment. Another way that we can help you save energy is by some filter innovations that enable you to achieve essentially the air quality or the filtration power of a MERV 13 filter without the energy penalty that comes along with that. We saw before in the energy department research that switching to higher level filtration does have an energy cost, and anybody who's done that has seen that in their utility bills. But there are some really great innovations in filtration that allow you to achieve the high level of filtration without the same energy penalty. In addition to that, the filters that we have developed don't have to be replaced nearly as often, and that reduces the maintenance cost and reduces the total cost of ownership accordingly. Now, let me turn a bit to disinfection and tell you a little bit about some of our disinfection products that I touched on earlier. So the first one I want to highlight is Beam. So Beam is a light that shines ultraviolet light across the top of the room. As you can see in this example in this classroom, it's mounted about 7 feet off the ground, and it's shining light up toward the ceiling and across the top of the room, not down toward any of the people who are in the space. And by doing this, it's able to achieve about 12 equivalent air changes per hour, depending on the size of the room. It works in rooms that are 500 to 2,000 square feet. It can also work in larger rooms if you install multiple beams. We've installed beams in many, probably hundreds of gyms across the country. So it's a very, very powerful way of achieving a lot of equivalent air changes per hour very, very quickly and inexpensively. It uses very little power. It uses about the same amount of power as a typical laptop charger. It actually has 4 LED lights in it, so it's a very efficient product. And it's only operating when people are in the room and for a short time after people leave, just to reset the pathogen load before occupancy resumes. So overnight or on weekends or whenever a space is not in use, it is not on. And it's very, very safe. First of all, as I said, it's mounted above where people are. And if anybody were to reach up, maybe there's some maintenance person doing something at the ceiling, it's automatically going to turn off. It's going to recognize that presence and turn off immediately. We also have a product called Vive, which is a far UV product that is often used in bathrooms or smaller offices. It's really great at controlling odors and disinfecting air and surfaces. And it uses far UV, which is a different bandwidth of the UV spectrum that is completely human safe. So it can shine down onto spaces that are occupied. It runs automatically whenever people are in the room. And again, like the Beam, it turns off when the room is not in use. And finally, we have the ARC product, which is our mobile UV tower. This is used for routine mobile disinfection. For example, at the end of the day, or if maybe there's a student who's been sick and you need to disinfect the space that they were in. This is the most powerful UV disinfection that we offer. This is wheeled into a room. You leave the room and it turns on for a few minutes, and 99.99 or more of the microbes in that room that you might be concerned about in just a few minutes. It's very easy to operate. You literally wheel it in, hit one button, walk out, and come back in a few minutes. And it's just plugs into a standard outlet. It can disinfect about 1,000 square feet. And just like the Vive, because it is disinfecting surfaces, it will neutralize odors. It will neutralize any mold spores that are on surfaces or floating around in the air. It's a really great product that's very popular in a lot of school districts across the country. One thing I do want to mention is we did a really wonderful study with one of the largest school districts in the US a couple of years ago, where we installed beams in classrooms, libraries, and cafeterias in 4 different schools for 5 months. And we compared the results in those schools with a number of other schools where those were not installed. The study was actually conducted by Dr. Edward Nardell of Harvard Medical School, who is a world famous expert on infectious disease transmission. And what we found was that we measured the presence of SARS-CoV-2 in the wastewater in the 7 schools that were in the study. And we found that in the 4 schools that had the beams, there was a 53% reduction of samples that had SARS-CoV-2 in the wastewater. So it was a pretty dramatic reduction. There were no incidents, no complaints during the entire study. So it's a pretty powerful example of the benefit of disinfecting the air in the upper room with Beam. So with that, I think we will just about wrap up and just share with you that R0 has been deployed at scale by customers across a variety of industries. Calling out specifically education here in the top middle, we are present throughout Clark County, Nevada, Fort Bend Independent School District outside of Houston, a very large district, in Memphis, in New Jersey and Elizabeth, here in the Bay Area and South San Francisco and elsewhere, in Dallas, and many, many other school districts across the country. And we've been really, really proud to work with so many great leaders in school districts across the country, as well as many, many other organizations, as you can see here. I think with that, we can wrap it up and turn to your questions. And I've been talking a lot, so I haven't been looking at the questions, but Michael, maybe you've been watching the questions and know what we want to jump in on.
Yes, thank you. I don't see any new ones that haven't been quite addressed yet in the forum, but we'd be happy to take any others that come in during this time. And if we don't have any now, please do feel free to reach out to us at any point after the webinar. We'll also be circulating the deck and the recording later this afternoon for those who want to take another look at it, or just share with any of your colleagues who may not have been able to attend during this time frame.
It looks like maybe one just came in. There was a question about small rural one campus district to apply.
So for a district of that size, really the best course of action is to see if there is an opportunity to partner with any other districts in your area to get to that 10 school facility minimum, and from there putting together a joint application for the Renew Americas program.
Really key question from Jeffrey: how does any of this apply directly to the grant application?
Great. So the grant application in phase one is really focused on your school facilities information. Where this information comes into play is when we start to talk about the technical narrative portion of the application, when they want you to start scoping out some of the ideas you have for implementing energy efficiency and IAQ projects in phase 2 and phase 3 of the program. So as already mentioned, when we think about air quality and energy efficiency, R0 is very focused on delivering solutions that address these directly. And we feel there's a strong match for the goals of the Renew America's Schools program right along those lines. But in phase one, again, really focused on the facility level and gathering that information for each of the schools referenced in the portfolio.
Jeff has a follow-up question about whether we have information templates tailored to the grant.
Yes, so we can help provide more detailed information and some additional content when you reach that portion of the grant, particularly around the technical narrative, and we'd be happy to connect directly on that after the webinar.
Yeah, I would say in general, we have a really strong history of partnering with schools and other public entities who are applying for grants for disinfection, for energy savings, for air quality. So we're pretty proud of our ability to help you do that. So if you're interested, very much would love to speak with you directly and help walk you through that step by step. There is a question, did the district have to be involved in round one to be able to apply for this round?
No, so this is a totally new round of funding that's open up to everyone.
I really love all of the detailed questions that are coming in. I think, as I said, if you have any interest in this at all, we'd love to keep the conversation going with you and answer those questions more specifically to your situation. So please do connect with us, and we're happy to walk through the details as they relate to you. Well, I think with that, let's wrap it up, Michael, and thank you all for attending, and have a wonderful day and a wonderful week.